So we have this function and we want to differentiate these functions. So in case of a, we have kx equal to square root of sine 2x all to the power half. To take the derivative, first we need to write this function. So k of x will be the same, which is the square root of sine 2x and all to squared. What I'm gonna do is I'm gonna transform the square root to the power of half, and then using the sum power rules I'm gonna multiply 3 by the half to become 3 over 2. Now we are ready to take the derivative. So we're gonna use the chain rule. So first we're gonna take the derivative of the outside and multiply it by the inside, and then 2 minus 1, and then multiply it by the inside, which is the derivative will be cosine 2x, and then multiply it by the inside, which is the derivative of 2x, which is just 2. Gonna simplify in here. Remember, this is the power of 3 over 2 minus 1. The power here should be half, I think. I think I made a mistake in here. We just subtract 3 over 2 minus 1. That should be the answer of that power. For b, what we have to do is we have to use the product rule. So I'm gonna assign the f function to e theta and g function to sine 2 theta. And then what I'm gonna do is I'm gonna take the derivative of each, so f prime and g prime. So the derivative of f is e theta and the derivative of g is cosine 2 theta, and we use the chain rule. That's gonna be 2 from the inside function. Now we are ready to apply the product rule, and this is what the product rule states. So what we're gonna do first is take f prime, multiply it by g, and add to it f multiplied by g prime. I'm just plugging what I found, f and f prime, g and g prime, into the product rule. You can factor e to theta, or you can leave it as it is. It's up to you, but that's the resulting derivative. Now we have c of x equals square root of 1 minus sine of x over 1 minus cosine of x, and we want to take the derivative of that function. First, what we need to do is rewrite the function. So that function, which is square root 1 minus sine of x over 1 minus cosine of x, can be written as 1 minus sine of x over 1 minus cosine of x all to the power of half. Now we are ready to apply the chain rule to take the derivative. Now first we have to take the derivative of the outside function, so they're gonna be half, and then 1 minus sine of x over 1 minus cosine of x, and subtract the half, minus 1, then it'll be minus half, and then take the derivative of the inside, which is the fraction. And what we need to do, since we need to take the derivative of a fraction, we will use the equation rule to do so. So again, we want to take the derivative of 1 minus sine of x over 1 minus cosine of x. To do that, we will use the equation rule. So the top function I assign it to be u, and the bottom function I assign it to be v, and then the equation rule can be written this way. Now again, u function gonna be 1 minus sine of x, and v function gonna be 1 minus cosine of x. Then I'm gonna take the derivative of each. U prime gonna be minus cosine of x, and v prime gonna be minus, but remember, cosine, derivative of cosine is minus cosine sine of x, so pay attention to the signs in here. So v prime gonna be sine of x. Now what I'm gonna do, I'm gonna apply the equation rule, so I'm gonna multiply u prime by v, and then subtract it by u multiplied by v prime, and then all to v squared. So again, d dx of 1 minus sine of x over 1 minus cosine of x gonna be u prime, which is minus cosine of x, multiplied by v, which is 1 minus cosine of x. I here run out of space, so what I'm gonna do is I'm gonna remove this part, and I'm gonna write it in a different place. So again, I'm gonna take that part and write it here. So I'm just applying the equation rule. So d dx of 1 minus sine of x over 1 minus cosine of x, and gonna be minus cosine of x multiplied by v, which is 1 minus cosine of x, and then minus u, which is 1 minus sine of x, multiplied by v prime, which is sine of x, and then all to v squared, which is 1 minus cosine of x squared. Now what I'm gonna do, I'm gonna distribute these terms inside so I can simplify later. So that's gonna be minus cosine of x, and then a plus cosine of x, and then I'm gonna leave the negative sign, and then later I would take care of it. So I'm just here multiplying, and then again all to 1 minus cosine of x all squared. So now I would take care of the negative. I'm going to distribute the negative sign to what's inside the parentheses. So that's going to be minus sine of x and a plus sine of 2x. Then all over 1 minus cosine of x all squared. Now remember this identity, which is sine 2x plus cosine square, sine square plus cosine square is equal to 1. Here what we notice, we have these terms, sine square and cosine square. Therefore I'm gonna substitute for these two 1. I'm gonna write what's left. So what's left is minus cosine of x minus sine of x, and then plus 1 from the resulting, and then all over same denominator. So what we found here is just the derivative of this, which is what we are looking for. So we need to put that back into the chain rule. So I'm just writing what did we found from the equation rule back to the chain rule, what we were doing in the first step. Now what I'm gonna do is rewrite and simplify this term. So you notice here, this is what's between the parentheses, it's to the negative half. This is the fraction. We can flip this fraction, so it's become positive. So I flip that fraction and the power will be half instead of minus half. And then I'm gonna write what's left, which is 1 minus cosine of x minus sine of x all over 1 minus cosine of x all squared. Now the power half also can be written as a square root. So we're gonna be square root of 1 minus cosine of x over 1 minus sine of x, and that gonna be the same. That is the resulting answer. So what we did, we applied the chain rule and we did the quotient rule, and from the quotient rule we went again to the chain rule and simplify and arrange the terms.